Hello, everybody. I'm Dr. Bob Morris, professor of biology at Wheaton College in Massachusetts. Welcome to another episode of Science with Dr. Bob. You know, I'm curious about evolution. You know I'm curious about evolution. But I'm also curious about Thai iced tea, because I love Thai iced tea. This is my version of Thai iced tea. And a Thai iced tea, that means Thai from, that's Thailand Thai. Thai iced tea includes cold brewed sweet tea on the bottom and a layer of milk or cream on top. And in fact, it is a quirk of water that allows Thai iced tea to look so beautiful and evolution to happen. It's a quirk that has to do with the density of water. The density of water in different states. So what is density? Density is the amount of matter packed into a space. The more matter that's packed in, the denser it is. And water has predictable properties as a gas and as a liquid, but unpredictable as a solid. Let's look at that. To see that, let's do an experiment. What I have here is some hot water. The first experiment we'll start with is to start brewing some Thai iced tea. So there's I'm going to get that started, and we'll come back to that. We'll come back to our tea at the end. In the meantime, I'm going to take our hot water and put some hot water in this carafe so it's easier to pour. And I'm going to top off this glass with hot water. And now to give us a couple different containers of water to work with. So there's our hot water. And I'm going to make this water, I'm going to make the hot water red so that it's real easy to see. It's just a little bit of food coloring. There we go. Want it to be very clearly red. There is our hot water. Beautiful. Now, we're going to do this experiment, we're going to compare the behavior of warm water with the behavior of cold water. So let's get some cold water, pour that into this carafe here. Go, 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 go. I want to try and leave the ice cubes behind. There we go. The carafes will make it just easier to pour. There we are. And to make it clear that we have cold water, I'll make the cold water blue. There we have it. Very, very blue cold water. Okay, now I'm going to add these different temperatures of water to water. So that's partly why I colored it, so that we can see the warm water when we pour it into the cold. There we go. Got about the same size there. Top that off a little bit more. And I'm going to add my warm water to the cold and my cold water to the warm. Voila. Okay, to see this experiment, I'm going to clear this area. And then I'm going to watch what happens when I add the hot water to the cold water. And to do this, so water mixed with water tends to mix very quickly. So to do it, it helps if you add it just to the top and you pour very gradually. So I'm just going to pour the hot water on top of the cold, and we'll see how it behaves. The way water behaves as a liquid is as you'd expect most matter. When you warm something, the particles in that thing get farther apart and it becomes less dense. And so warm water floats on cold water. But what happens when cold water is added to warm water? There again, I want to pour it right in there. Well, lo and behold, there you have it. The cold water sinks relative to the warm water. That's not a surprise. That's how matter behaves. As the particles get colder, they get closer together and they become more dense. So I hope you can see that the blue water, the cooler water sank towards the bottom and the warm water kind of floated. It kind of stayed on the top. Well, that gives us a prediction then. Because water, if it were behaved like other matter, then as it cooled, it would get heavier, it would get denser, and then the coldest water of all, solid water, ice, well, it should sink. But in fact, you know that solid water doesn't sink at all. Solid water floats. And that is just a chemical paradox. It is just an oddity of water. And that's why Thai iced tea is possible to have this beautiful separation, and evolution is possible on this planet because we are water-based life forms. And and the best evidence suggests that when life got started, it started as cells and molecules on the bottoms of liquid spaces, on the bottoms of tide pools probably. So that is great for those tide pools, but not in the wintertime. If water were to freeze from the bottom upward, life would not have evolved on Earth. But because of this quirk of water, that solid water floats on liquid water, as ice would, as water would freeze, it would float on the top of the pond. And to this day, fish and frogs and turtles are very lucky that the ponds freeze from the surface because of that quirk. Solid water floats, unlike most solid matter, which sinks in its own liquid. So that brings us back to Thai iced tea, because Thai iced tea, you can use this quirk. You can take cold tea. So there's our warm tea. I'm going to let that steep for a while. I pre-brewed some cold tea, and I'm going to make iced tea with that. There we go. And then on to the iced tea, I'm going to add a little bit of sugar. That actually increases its density even more. You know that cold water sinks, but cold sugary water sinks even more. So there's our sugary sweet tea. And if it were true, as we demonstrated it is, that warm liquids float on, warm watery liquids float on cold watery liquids, well, this is a cold watery liquid, and we can just take this milk, which I've actually warmed to room temperature, and we just pour it right on top of those ice cubes so it doesn't stir in instantly. And sure enough, the warm liquid, the warm watery liquid, is floating on the cool watery liquid. And we get that beautiful drink, Thai iced tea. You can do this also with iced coffee, with any drinks that have a sugary, cool lower layer and a watery or warmer upper layer. So I encourage you, try this experiment at home. It's amazing that because of this quirk of water, not only can we make Thai iced tea, but the life has evolved on this planet, starting at the bottoms of tide pools, and water would freeze on the surface and leave life alive on the bottoms of those tide pools as it was getting started over millions of years. So I encourage you to try this experiment at home, and until next time, keep on experimenting.